Hello everyone, welcome back to my channel. In this video we will learn what is Docker, what are the different concepts and how to install Docker on different machines. So let's say whichever machine you have, we'll see how to install Docker on that. We will understand different commands. We will do hands-on for each of the command. We'll understand each keyword for that command, and also we will understand Docker logs also, so that it will help us to identify the issues whenever we come across. So let us get started. So to install Docker, you just have to go to Google, just type Docker desktop for whichever OS you are using. I'm using Mac, so I'm typing Docker desktop for Mac. You'll have the, just go to this Docker desktop link, and in here select your OS. So for me, I'm selecting this Mac uh, link, and you have to select respective OS whichever is related to you. Now once you click on that, right, just click on this link, a file will get downloaded. You just have to double click on that, and you have to install. As already I have it, so let me just show you. This is the Docker desktop. When you install Docker desktop, you'll have different options on the left side. If you see, there is a container section, there is a image section, volumes, dev environments. So image section, it has all the images. Container sections, it has all the containers created. Volumes, it will show all the volumes created, right? So if you see on the top, there is a button here where you can pause, you can restart, or you can quit the Docker desktop. So we will not spend much time here. We will straight away jump into the concepts. First we will understand what is an image, what is a container, right? So let's understand first what is an image. So Docker image is basically a package. So it will help us, like, it's a package. It contains libraries, code, runtime, and whatever the tools that are needed. So with the help of these things, uh, it helps us to run this image across different environments, like different systems, different OS. So if you go by the definition, it says like Docker image is an executable package that includes everything needed to run a piece of software. Like basically, whenever you see any Docker file, it has a number of instructions. It has the instruction to copy the code, to download the base image, to download required libraries like Java. So all of those things will be there as part of this package. So container is basically, if you try to understand what container is a runnable instance of an image. It's like when you create an image. For example, you created an image for MySQL, and if you want to create a container out of that, you just have to run that image. So when you run that image, it creates a container. So for example, to understand image, let's take a object oriented programming like Java, where you'll have classes and you'll have objects. So if you compare image and class, both are similar. So class has a predefined set of properties and behaviors, whereas image has set of instructions. And in Java, what do you do generally with the for that class? You create n number of objects. Similarly, in Docker, what do you do for single image? You create n number of containers. It's like object is a runnable instance for that class. Here container is a runnable instance for this Docker image. Just remember this comparison, you will understand. So if you see here, it says like it's an isolated process running on a host machine. So basically this container, it says it's an isolated process where it is not interacting with any host machine processes, right? You can create n number of containers for one image. It depends. Why do we create n number of containers? Let's say if you want to understand, for example, uh, there is a web application, you have a front end, you have an API, you have a database, right? For that things, right, you create different containers, and you allow the containers to talk to each other, and those containers will be hosted on production servers. So let's say you want to have a lot of traffic on your website, and single container can't handle all those traffic, so it has to be it accepts only a limited amount of requests per second. So in order to accommodate millions of requests per second, or in a limited time, we have to have something that can handle that. So for that purpose, what generally we do is we create n number of containers for that, uh, for those Docker images. Let's say you have a front end container, and back end container, and database container. For those things, you do generally like auto scaling. Auto scaling is increasing the number of instances of containers. So it's an uh, it's a vast concept. If you have to understand, we'll have to go with Kubernetes. So for now, we'll just understand that we can create n number of containers with a single image. So containers, we can run it as part of local machine or VMs, or we can deploy it to cloud. As I just said, now we can deploy it to cloud, the same thing which I explained before some time, right? The same thing which has been mentioned here. We can run it in any operating system, okay? And these containers, it is isolated, so it has its own software, binaries, configurations, etc. Now if you try to understand what are different commands, so let's understand practically with the help of uh, our terminal. So to start with, what I generally I'll do is, let's type our first command. Whenever you install Docker, you just type this command, docker space hyphen hyphen version. So when you do that, so what will happen, it will show the Docker version. So it is saying that Docker version is 24, and specific build number also it is mentioning. Now let's say you have uh, installed Docker successfully. Now you want to do something on the Docker, right? You want to have some image, you want to run some container. So what do? So for that, what do we generally do is, let's go to one website. I'll just show. So there is a website called Docker Hub. You just have to go to this website, click on the first link, hub.docker.com. When you click on this link, right, you will have this page where you can search with different images. Let's say I want to search for MySQL. So it has a lot of images, which are some of most of them are official images. Others are also there where people write their own images and push the images. It's like, assume like this is like a GitHub for developers. Whoever writes some development code, they push their code to GitHub, right? The same thing you can assume for Docker. Docker is a repository, central management repository for Docker images. So it has lot of images. If you see, it has MySQL, MariaDB, and whichever you want, you will find it mostly. It also show like how many downloads we have, okay, how many people pulled it till now. Like if you see here, these many people pull this. And if you further want to understand, you just have to click on here. If you'll get a lot of details. It has different tags also. It has different tags for this image. It has a command needed to pull this image. You can copy it from here. And also if you come here, right, it shows like what are different supported tags for this, and what are different references we have. So also it has a very good documentation where you'll try to understand how to use this image, how to run this image for creating a container, everything you'll have. So maybe we can have it discussed separately regarding MySQL. So if you, it has different other images also. If you see type Mongo, so it has the image for MongoDB also. Just click on that. So these are the different images we just saw. So it has the instructions how to use Mongo, how to start it, what are the different parameters. So what we will do, we will just we'll just pull one image. We'll say docker pull and image name is mysql. And what do we generally do, we give the tag we are using latest. If you don't mention the tag, it will by default pull the latest one. So I'm mentioning tag also here. Docker, what is docker here? This keyword represents that it's a command line tool. Okay, pull is saying that download this particular image. So this is the image name and this is the tag name. So we will just hit enter, and if you see, like, it will start pulling the image. So we will understand each and every line which we have got in the logs. So let it pull it. Here you can see like extracting, and it was showing that size also. So if you understand this thing, right, this is, it says latest is whatever tag we just mentioned, and pulling from, it's mentioning the path also from where it is pulling. If you see library slash mysql, so here mysql is the image name, library is the organization name. So by default all the official images will be in this organization library. So now if you see, there is some unique code and it says pull complete. So if you see, all of these are layers. So docker, what it does is, each and every instruction it tries to create a layer for that. There is a reason behind that also why it tries to do that. So based on the layer it tries to pull. So what it does, let's say you write something in docker file, for each and every line it creates a layer, it caches it, and then uh, it stores it in our local machine wherever we are downloading. So the reason is, let's say you want to download, you make some changes in some code and you want to build the image again. But the thing is, if you want to build the image, what docker does, it only rebuilds the layer wherever the code change is made. Let's say code change is made in the some config file, and this is the layer that caches that config file. So it only rebuilds this layer, and the all the other layers it will not rebuild again. So for that purpose, docker uses a layering mechanism. So if you see this digest we have right here, it says like digest, and it gives uh, some two SHA256 code. So it means that the integrity of this image is maintained. It's not corrupted, if you get this. And status, if you see status, it mentions that. So it says that the image is successfully downloaded for this image name and tag. Okay, and finally it says docker.io slash library slash. So docker.io is a registry. So registry is like Docker Hub. If you see, this is Docker Hub, this is the registry, and here you have this organization and you have this image and the tag. So now we understood the logs produced by docker pull. What will happen if we again try to uh, hit the same command, docker pull mysql colon latest? Let's see. So what is happening now? See, for the first time it, the logs are these many lines it produce, and for the second time only few lines of logs are there. So what it's saying, it's saying latest pulling from so and so, this org and this image, we don't have any layers here in the second time, because there we have not changed anything, already we have downloaded, so it by default it will take it from the cache. So it is given the digest also, because nothing is corrupted and image is up to date. Okay, now we pulled an image, we will try to understand the other command. Let's say I want to see the image. So what is the command? Docker image and ls. So what is ls here? Ls is basically a list here. Ls stands for list. Okay, if I hit enter, it says what all, it shows what all images you have in your machine. So it has different columns: repository, tag, image id, and when it is created, and size. So we have three images: MySQL, MongoDB, and API's image. And what is the tag? Tag is latest. And what is the image ID? Image ID is generally uh, ID assigned to that image, and it says when it is created, and what is the size. Size is size of that particular image. Okay, we have seen the images, we have we have pulled the images. Now like you can let's see what else we can do. So I have a document here, I'll just refer. We understood the logs, we uh, list all images. Okay, now we can do is we can remove an image also. So let's say if I have to remove an image, what do? I can say like docker image rm and the image name, let's say mongo. So if I hit enter, it says untag and mongo latest. So what does it mean? So he here you have this latest tag, right, for mongo. Whenever we delete any image, first thing it does is it removes the tag for that image, mongo. Okay, now it removes this digest also, and it has deleted all the layers. Right, now if we see again, docker image ls, see, we don't have mongo listed here, mongo is gone. Now if I pull again mongo, so let's see again. If you see, if you pull, it is again downloading all the layers, because we have deleted the existing image and all the layers. Again when we pull the next time, if it will check for the layers, as these are not present, it is again pulling those. Okay, now we have removed the image also. Let's check what all images we have. Docker image ls, so we have three images here. We can remove an image with the help of we removed with the help of name, right? We can remove by id also. Let's say docker image rm and id, let's say this. So if I give id also, it will remove. See, mysql, it removed. Now one more thing I want to show. Not only rm, you can use remove also, and let's say I remove this mysql. Okay, mysql already we removed. I remove this mongo, sorry, we, okay, fine, mongo I'll remove. See, it remove mongo also. Let's list down the images what we have. We don't have mongo and mysql, so let us download again docker. Let's pull mysql. See, I have not mentioned any tag, by default it will download the latest one. Okay, see, it's downloading each and every layer. Right, now what we will do, we will again download mongo. Now docker pull mongo. Okay, it will also download the latest one, as we have not specified anything. For the first time it will take some time to download, and whenever you try to download with some change in the second time it will be quicker. Now we will again list all the images, docker image ls. So it has, we have three images now. Now let's say I showed you, right, docker image remove. I can remove by using this id also. Let's say again we remove MySQL. Okay, it got removed. And if I again list the images, so it has, we don't have MySQL here. Again docker pull MySQL. So it's again downloading MySQL and storing it as layers. Right. Now what we do, uh, let's see other commands. We have saw the image history. Let's understand. So there is one more command called docker image history and MySQL. So what does this command do? So if you try to understand what this command is, it basically lists down all the instructions that has been used to build this image. Let's say it has all these layers. If you see this image, okay, if you see these are all created by these commands. Okay, cmd, it may have internal images also, internal images also being used to download it. So all these commands it has used, cmd, expose, entry point, copy. So all these commands it may have used. We can check it for mongo also. Docker image history, and we can check it for mongo. See, mongo also, what all commands it has used for building that image, all those it has listed. Now if we further move on, we have other commands also. Let's say if you want to display all the low level information of docker image, like which all containers it is using, what is the network it is following. So let's see that. Let's say docker inspect mysql. See, if you type docker inspect mysql, you have got something like json. Okay, so it will display like what all properties it has. It says the tag, what we have, like parent image. If there parent image here, nothing is there, right? And container config, if container is there, what all different properties of that container it will mention. Okay, when you actually try to run this container and do inspect, right, then you'll get a lot of information here, what all network and all. Okay, just you can, maybe you can go through all of these. The other thing is like we have prone also, docker image prone. So let's say if there are images, let me clear it. Let's list on all the images, docker image ls. Now you have three images. And let's say you have all your spaces is full, space is full for your machine, and you want to clear unused images. So what do? You just say docker image prone and hyphen a. If you do what it does, it will say like this will remove all images without at least one container associated to them. Are you sure you want to remove? If you say yes, it will do it, otherwise no. I'll say y, enter. See, it deleted all the unused images, and it says total reclaimed space is 1.343 GB, right? So these are all different commands we just saw as part of docker. uh, these commands are all related to images. We have not yet started with containers, so we have a lot of commands with respect to container as well, that we may see as part of next video we may list down all the commands as part of container, and further we can go ahead with different concepts uh, related to that. So that's it in this video. I hope you like this video. Please share in your group and subscribe to my channel. Thank you.